Next installment in my video lecture series in economics. And in this particular video lecture, I'm going to be taking a look at exchange efficiency. In particular, giving a numeric example that illustrates what is meant by exchange efficiency. So starting with, we have utility tables for person 1 and person 2, looking at consumption of apples and oranges. The table includes total utility of apples and total utility for oranges for each person 1 and person 2. The way to interpret this table, for example, if person 1 consumed 4 apples, those 4 apples would generate 149 units of total utility. Or if we gave that individual 2 oranges, those 2 oranges would generate 118 units of total utility. Okay, same thing holds for person 2. The marginal utility is just the increase in total utility with the consumption of an additional unit. So if we're looking at apples, it's the increase in total utility when consuming an additional apple. So when you consume no apples, this person generates no utility. When they consume the first apple, their total utility goes from 0 to 40, which means that first apple generates 40 units of utility. So all we're doing here, if you're looking at this in a spreadsheet fashion, is that it's this cell here equals this cell minus that cell. And if you copy that down, you'll get the correct result. So from here we have 79 minus 40, which is 39, etc. And the same thing holds for person 2. So to take a look at this, we have to allocate the resources between these two individuals. So let's just say, for purposes of fairness, that we're going to give 4 apples to person 1, 4 apples to person 2, 4 oranges to person 1, and 4 oranges to person 2. We're going to be split evenly, all our resources split evenly between these two individuals. So we have this blue highlighted area here to indicate that. And for some information, we calculated the marginal rate of substitution, which is the negative of the marginal utility of oranges divided by the marginal utility of apples. So 88 divided by 24, the negative of that is negative 3.67. Same thing here, 48 divided by 33, the negative of that, it's negative 1.45. And for more information, we have what the total utility is from this allocation. Here's the total utility of person 1. 149 plus 220 is equal to 369. And then 110 plus 380 is equal to 490. Add those together, and that's the total utility of the allocation of these resources between person 1 and person 2. Let us say that person 2 decides to offer person 1 an apple in exchange for an orange. So person 1 is going to give, person 2 is going to give person 1 an apple, and person 1 is going to send back an orange for that apple. Is this a sensible offer for person 2 to make? It is a sensible offer, okay? Because if this offer is accepted, their total utility will increase by 52 units. Their fourth apple generated 24 units of utility. So this apple is now going to be sent to person 1, which means total utility is going to decrease by 24 units. When they receive the orange, that 5th orange is going to generate 76 units of utility. So 76 minus 24 is equal to 52. So this is a sensible offer for them to make. Remember, it has to be a sensible offer for person 1 to accept. Is it sensible for them to accept this offer? It is not sensible. Their utility is going to go down by 20 units because they're going to send an orange that was generating 48 units of utility to person 2, which means total utility is going to decrease by 48, and they're going to receive a 5th apple, which is going to increase their utility by 28. So they're decreasing their utility by 48 and then increasing it by 28. The net change is a decrease and 20 units of utility. It doesn't make any sense for person two to accept this offer. So it is, quote unquote, declined, denied, whatever you want to say. However, person two can make a counteroffer. You say, no, you know what, that 1-to-1 for oranges and apples, I'm not feeling that, but I am feeling if you send me 2 apples and I send you 1 orange, I'm all right with that. Is that sensible for that person to make, for person 1 to make this offer? Does make sense, because their total utility is going to increase by 2 units if that offer is accepted. Why? Because their utility is going to go down by 4 units. That's the orange that gets sent to person 2. But they're going to gain a 5th and a 6th apple, which generate 28 units of utility and 22 units of utility, which is 50 units of utility. So if the offer is accepted, their total utility, the total utility of person 1 is going to increase by 2 units. Again, it has to be mutually beneficial. Will person 2 accept this offer? So they have to send, and as it says right here, it is a sensible offer to accept because total utility is going to increase by 25. What's the cost to person 2? Well, they have to give up their 4th apple and their 3rd apple. 24 and 27 is equal to 51. That's how much utility is decreased. And when they gain the 5th orange, their utility goes up by 76 units, a net increase of 25 units. So as you can see here, they accept that offer, and now here's the total utility of this new allocation. It's 886 units. Person 1 is made better off. Total utility goes from 369 to 371. Person 2 is better off. Their utility goes up from 490 to 515. So both parties are made better off. Total utility is increased by just reallocating those resources. Okay? So as you can see here, exchange efficiency just occurred, right? The allocation of equity, everybody getting the same amount, did not maximize utility. All right? So it was not Pareto efficient because we found a trade that made both parties better off, which means it increased total utility. So the initial allocation was not Pareto efficient, and engaging in this exchange illustrates why that was not Pareto efficient. Now let's take a look at what the marginal rates of substitution look like for these two people. What do you notice? That they're getting very close to one another, right? Originally, it was negative 1.45 for person 1 and negative 3.67 for person 2. After the exchange, what have we noticed? That they've gotten much closer to one another. The MRS for person 1 and 2 have changed and gotten closer to one another. So when you read in the textbook that when they're saying that the marginal rates of substitution for two goods must be the same for all individuals, etc., we just illustrate that we're moving towards that point of where the MRS are equal to one another. So the existence of the difference between the MRSs indicates that there's a possibility that mutually beneficial exchanges exist.